Yeah. Okay, we at National Grid we start everything with a safety moment and safety message, and it is one of our top priorities. But something that's near and dear to my heart is stress and stress management, and we've created an environment where we're almost constantly in stress, and that is something that needs to be managed. I joke about it, but television has even become stressful to watch now. It used to be a commercial came on, you closed your eyes or did something, but now you jump over to another station or another 2,000 stations. So some of the techniques that we say here are 5 healthy techniques that psychological research has shown to help reduce stress in the short and long term. Take a break from the stressor. It may be difficult to get away from a big work project, a crying baby, or a growing credit card bill. One of the things that I try to do is when I'm at work, I try to forget home. And when I'm at home, I try to forget work. I'm not always successful at it. Exercise is a big one for me. I exercise aerobically 20 to 30 minutes every day. I don't like to exercise, but I know it's something I need to do. Smile and laugh. I'm a big proponent. I want to try to get a belly laugh for a light moment at least once in my day. And then social support. We try to tough this stuff out and do everything alone, but you really can't do everything alone. And there's lots of support networks out there to help out, and I recommend you use them. And the last one, number 5, is meditate. Something I actually do participate in meditation, and when I first started out, I had to work at it. I couldn't sit for 1 minute quiet. I set my timer for 1 minute. It seemed like an eternity. Now I set my timer for 20 minutes to remind me to stop meditating. And one of the things that the class I took on meditation, the book I read, says we have 45,000 to 65,000 thoughts a day go through our mind. And most of them aren't positive. And again, more stress related. So try to moderate stress, and we'll go to the next slide. Right, the agenda today was a safety message. Then I'm going to do a little bit on what the goal of this presentation is, and then Tim and Chris are going to go through the technical components of the presentation, and at the end we'll do a review and an overview, and that's it. So if there's any questions, we'll get moving. Tim, go ahead. The goal here is for all of us. I tried to narrow it down to what it is, and it's resource management, right? Time and money. So I know the developers I work with, as well as the customers and developers, and as well for us, is our technical resources are at a premium. We're getting deadlines that are shortened for us all the time, and we're trying to manage a lot of projects, all good stuff, but we need to be considerate of those resources. So if we can streamline the submittal process, if we can streamline the number of submissions, we will better manage those resources. And then, we charge for our resources at what they actually cost. So if we can spend less time looking at multiple submissions, searching for documents, looking for files, we're going to save everyone money in the end. So we can also prevent project delays, unnecessary delays. So if we get our submittals in, we deliver them clean, complete, not in sections. Don't deliver more than we need. We have people that have a habit of sending us hundreds of pages that we don't necessarily need to review, but when we're looking at them, we are spending time and we're using resources. So the goal today is to hopefully make this an easier process of submission and submittal review. Go ahead, Tim. So the submittal stages are, number 1 is the application stage. Number 2 is the CESIR, or full study submission. Today's webinar will discuss submittal. I like that, just uses. That's when I should proofread my stuff. We'll discuss submittal stages 3 and 4. The initial site visit and kickoff meeting, and then the construction. And something I want to reference, even though DG is new or relatively new, 5 or 6 years, Our ESBs, engineering service bulletins, have been around for a long time. In ESB 751, Section 5, Stage A and Stage B have definitions and what's included in these submittal documents. So, and I referenced down below under that bullet, it says site plan. That's what's written in there. That's what we need on a site plan. So if you want a reference document, you can go to the ESB 751, Section 5, Stage A, or Section 5, Stage B, and get the details of what are necessary to be in the submittal document. So that is our plan for today, and with that, I'm going to turn it over to Tim and Chris. Thanks.
All right, thanks, Gene. So, as Gene mentioned, we'll kind of take a step back in time here before we get to the initial site visit, just to kind of review on how we got to this point. If you recall, your initial application went in, you paid your application fee, the application was reviewed by our screening team, a preliminary study was done, and then delivered back to the applicant. From there, they decided to move forward with the full study, paid the fees to have those studies done, and then provided any additional documentation that was required to get the study done. Once the study was completed, given back to the applicant and the customer, and from there, they reviewed it, had a review session with National Grid, and now we decide to move forward into construction. So first step was to have the initial site visit, go out and talk about things, take a look at things. But unfortunately, there's a misconception that once you pay the 25%, we're ready to go out and have that first site visit. Unfortunately, that's not the case. What we need to do is we need to get the site plan showing the customer interface pole, the meter pole, and all that. We need a proper site plan so we can get out there. We also have to have the poles staked out in the field along with the property lines and the access road. So when we go out there, we'll be able to see exactly where everything is going to be. And then if there were any changes during the study period, like if the generator info changed, we'll have to get that information updated, an updated Appendix B, an updated single line, and an updated 3-line. So just to start with the site plan, because typically this is really the only thing that needs to be updated once we do go out for that site meeting. Let's just take a step back again and look at all the steps that we can go through for a site plan. What you're looking at now is really the initial site plan that was made with the application. Fairly basic. You can see the arrays cited on here. The customer has his potential location for his equipment. There's a potential location for the point of common coupling. The roadways are shown, and there's a compass arrow shown. Also note that although the title block here is blank, it should have the site name and the site address on the title block, just in case it does get separated from everything. We know what this site plan is for. Again, very basic, filed with the application. Now that we're moving into the construction phase, we want to see something a little bit more detailed so we can have a productive site meeting. And this is what the customer should be producing. Again, a little bit more detail. You can still see the array, a little bit more colors now. You can see the access road that was put in. You can see fence lines, property lines, still see the roadways. A little bit more labeling. We see the point of common coupling label, all the customer poles labeled along the access road, a little bit more detailed. And again, we got the compass up there. Again, the title block, same thing. Make sure the customer site name is on there along with the address, so we're able to reference that.
Yeah, just to add in there, Tim.
Yep.
On the last one. So as we progress down this more detailed submittal package so we can coordinate the layout and agree upon the layout of the site, another key component here to this site plan would be scaling. So on the detail plan, once you get to that stage, it should be pretty set that you have everything laid out and it spatially makes sense, and the scaling on the drawings, as well as maybe some reference scaling on like from point to point on some physical attributes, maybe the site width, as well as a scale bar and the units of scale in the title would also greatly enhance the ability for the engineers to coordinate and make sure everything makes sense and it's going to work.
All right, thanks, Chris. Good note. So again, this was the site plan we used to have the initial site visit. Based on those discussions, we move on to the next site plan, which is really the final version, a revised version based on all the comments that were made out in the field. And as you can see, we still have the array here. The access road is still there, but now the pole line has moved from the west side of the road. If you recall from the previous one, the pole line was on the west side of the road. Now it's moved to the east side of the road. And along with that pole line, we show dimensions between poles. The notes are updated and any more detailed notes are shown. And again, the fence line and the property lines are shown. And this one's really ready to be PE stamped. Chris, anything else to add on that?
Well, you covered a lot of it, Tim. So when you get to the pole design, this drawing in here, it really shows a great illustration of that, where we show the physical spacing of the poles. There are minimum spacing requirements that we would have for the poles of mutual interest, especially revolving around the gang switch, the metering cluster. There are minimum space requirements for that. To show that, it's good. If this was, for instance, if this was a sub-transmission design, having the appropriate width as well, showing the right-of-way path for that would be something of interest. So good quality design showing the detail of the drawings, showing the right scaling or the dimensions of interest. That's really what we'd be looking for here. Now, this would be after a couple negotiations, so if you weren't showing some of that, we would most likely help guide you towards that. But really, that's what we're looking for, is the scaling and dimensions and the appropriate equipment identified on the drawings, so we can make sure that when we discuss with you or your engineers, everyone is speaking the same language. We're able to communicate clearly and efficiently, so we can expedite your project from start to finish and be more of a support role versus some kind of an inhibitor or obstacle. We don't want to hold you up, so the more detail and information we can have to communicate, the faster we can get you through the process.
Okay, thanks, Chris. Yeah, so hopefully everyone could see the progression of the site plan, how it progressed from the application period to the site visit, and then adding all the comments and finalizing it after that site visit. You can see how much more details went into it, so on and so forth. Another aspect that I mentioned was the staking. And I purposely picked this picture because there's a lot of vegetation there. And a lot of times we think of a site visit, a lot of these solar farms are located in farmers' fields where they're fairly open. There's not much vegetation. It's probably pretty easy to see where the property lines are. Could even probably depict on where you're going to put the access road, things of that nature. But it's not always the case, and we do have to have everything staked. So we always ask that everything be staked out in the field prior to that initial site visit. And here you can see the stakes are out in the field. I had to circle a couple of them because they do get lost in the vegetation, but you can see they all lined up. You can also see the property line stake. I don't show the access road stakes here, but they're within those circles. There's actually two stakes within some of those circles back there that you can see. But again, everything's marked out in the field, so it's easy for us to pick out. Chris, I don't know if you got any other comments on staking for the field.
It will be important, and it can facilitate not only the access roads, but where your pole locations are. If you could just put a stake down or identify those locations as well, so when we come out, we can physically see the approximate or the anticipated location of those pole layouts for anything that's an overhead service. And then we can have discussions on whether they would need to be readjusted or if they're appropriate or anything else that would need to occur.
Okay, thanks, Chris. All right, I had also mentioned that if some things have changed, that there have to be some updates to the single line, 3-line. All that information is found within the CESIR, and also, as Gene had noted, that you can go to our bulletins to look for some guidance on what needs to be included in single lines, 3 lines. But for those of you who've had applications with us in the past, this may look familiar to you. This is part of the what are our old package of the CESIR, where we've provided some written notes in section 6 to what updates need to be made by the customer and their drawings and anything else that's required. We've moved on from this type of format to a new format for the CESIR, and now you're going to see everything in what you see here in an Excel format where everything's listed out, and those comments are all listed out in a spreadsheet format. So it should make it a little bit easier. It condenses them, and it kind of acts as a checklist or an action items list for you, and then it's easy for everyone to reference as we go through and we have our conversations on a weekly call or however. So hopefully some of you have had some new CESIRs come through and you've seen this new spreadsheet. I like it a lot. I think it's going to streamline the process for us all and make things a lot easier for everyone going forward. Chris, anything else to add on the comment?
Yes, so this comment sheet is something that we've some of the engineers within our company have used this in the past, so I don't want to say inconsistent because quite a few people had a different version. And this really, we took what we were doing before as past practice and we brought it forward in conjunction with the new final CESIR template update that we did statewide across all utilities. So now this document is a supplement to that new formatted final study in order for us to start communicating with clarity some of the needs or changes that we've observed on your drawings that aren't necessarily study impacts, but they are impacts that we are highlighting up front, so we again can pull forward that discussion in order to make sure we can make the right changes as early as we can identify them to again help process your project from construction to finish in a timely manner as swift as we can support that project occurring.
Okay, great, thanks, Chris. All right, so now that we've gone through the site visit, we made any updates and all that, we can move on to the design stage and the final schedule. Once we receive all those updates, we can get all that information out to you. In order to move on to this design stage, we need to see what's called a pole arrangement drawing, which is really the first pole into the property, and then any finalized locations of the poles that were staked. So if things have changed out in the field from our initial site visit where we may have moved poles, like in the example I showed where we moved them from the west side of the road to the east side of the road, that needs to be restaked. And then that site plan, as I said, we got to that last site plan. It's almost ready to be PE stamped. Just do a final cleanup on it, give that PE stamp to it, and get that out to us, and then we can create our schedule. Chris, I don't know if you have anything else to say on that. If there is any questions, again, refer to our bulletins or to the CESIR for questions. Chris?
I think you covered it. I guess one of the more important items, just to reiterate on the last bullet there, the site plan, no PE stamp yet. We were in past practice, we may have required that this drawing be PE stamps right out of the gate, but we've relaxed that a little, understanding that there are iterations that occur, and through natural evolution of drawings within within consulting firms, they may not want to spend the effort to stamp every iteration. So we allow that negotiated design to occur until we get to a state where we're satisfied with the arrangement, and then we would require those stamped drawings. So it makes it a little easier when you're dealing with your consulting firms or your in-house engineers as to when we require the actual sealing of the documents.
All right. Oh, what happened? Okay. So again, moving into final design, we mentioned that the pole arrangement drawing, I have a pole arrangement drawing here, and Chris, I'll let you speak to that.
So yeah, so this has got a lot going on, and this is a good example. It's not the end-all be-all for drawings. There are other drawings that are equally as good, but this is a good example for us to speak to. Now, on this drawing, it shows our pole arrangement. So this gives us a couple different vantage points. It gives us a side profile. It gives us a top view through a section cut. It gives us another section cut of the other side profile. So I have two sides visible plus a top view, this also takes the extra element of an isometric view, which also can lend to usability by the reviewer. So these are all good examples of the different angles that we would like to see. And now the isometric may or may not be necessary depending on the congestion of the pole or whatever device you're trying to illustrate or demonstrate on the drawing, on the specific drawing. But the quality of this drawing also, or the level of detail in this drawing is also something of interest. It has a lot of dimensionalization on there. It shows dimensions from ground to, well, the burial depth of the pole, which is of interest. It shows the pole height. It shows heights to the neutral. It'll show heights to the primary equipment. It has a lot of labeling and notation to identify each part and piece. On the side views, it gives us more spatial relationships. So it really does a good job at laying out all the parts and pieces to connect. So it paints a well-illustrated picture for, again, the reviewer, so the engineer at National Grid reviewing the project, to make sure that we are confident that you guys are putting in an installation that satisfies our ESP requirements. And so much as to goes into the details on the grounding arrangements and the connectors as well. So it does a good layout, a lot of detail, and that's really what we look for, is that kind of dimensionalization or the details, so we can get a confident understanding of your project. So by the time we get to the field, we don't have those discussions about missing ground straps or some kind of a bonding that should occur at one point versus another.
All right, thanks, Chris. And then just to take this through for the design stage, as we said, we needed the pole arrangement drawing. If any stakes need to be relocated, you need to do those out in the field. And then any final updates to the site plan, those need to be completed. So that's really the complete package then. So we can move on to our final schedule. From there, once we get all that, we will develop our final schedule. And it's important to know, we showed the action items list, the Excel spreadsheet that you get in the CESIR that lists some things that need to be done. This is another milestone schedule that's put out by our resource coordinator with some additional information, some things that need to be done. Just keep in mind, this is not an end-all, catch-all milestone. It is one piece of it. We do like to use it to discuss with our customers, but it shows some major milestones. For example, like the site visit. In this example, we had it on the 20th of September. Then for us to order equipment, we started that October 3rd and went through the 24th. Recloser settings were done in January through February. Permitting, which is, or easements, excuse me, which is required by the customer from the 15th of January to March 16th. So we'll give everyone an idea of how things should flow, when things are due, in order to keep your project on schedule. Then we'll move on to the customer design and construction review. Now, to start that, we're going to need a full package of drawings and submittals, the PE stamp site plan, the PE stamp single line, 3 lines, PE stamped AC/DC elementary, the PE stamped electrical assembly and profile drawings, any relay settings if they're required, protective device coordination studies, labeled equipment designations in all the drawings, and then any cut sheets that are associated with your project, such as transformer, grounding banks, reclosers, fuses, and switches. And Chris will get in that in a little bit more detail as we go on. So again, just for a review, the PE stamp site plan, this should look familiar to you now. It's pretty much what was done after the initial site meeting. So nothing really new here. Get into the single line diagrams and all that. And Chris, I'll let you start talking to what's required here.
Yeah, so on the single line, and this should be a well-developed document at this point, because this would have been required a few stages back. But on the single line, I guess one thing I'd like to discuss first is the legend. There's a legend on this drawing, and the legend used here is just simply describes the symbology used within this drawing. And maybe the legend is also transferred. It's shown in this drawing, and the symbology is used on other drawings as well. But this gives us again, a firm understanding as to what an individual component or device means. So, and not everyone uses the exact same symbology. There may be slight tweaks or differences to their symbols used. So having that legend to describe what your symbol means is a very important information. Now, if you need help deciding what a symbol should look like to represent a specific device, such as a switch, a hook stick switch, a gang-operated switch, fuse holder, transformer, whatever that device may be, we did take a lot of time and effort to provide a general symbology list within our ESV 756 series, and there are symbology in the 753 and 50 series as well. So if you were to take a look at those documents, the symbology that we added there was in an effort to help guide choices when it comes to creating your own symbology for your drawings. So when you present that information, there's certain items that should generally look similar across stuff, you know, if you were to pick up one set of drawings from one consultant from another. So that's to guide and help, and it's very important to have that symbology. Now, what's important on the drawing is anything that would be of interest to the utility. So with that being said, so you're going to have, in this example, an overhead primary service, a three-phase gang-operated switch. So that would be of an interest, so we would want to see that type of device on the drawing. If there is a protective element that's required by us, such as your primary overcurrent protective device, that item should be shown on the drawing. Any protective relaying elements should be represented on here, and their instrumentation transformers that feed into those elements are something we would require shown on the drawing. On this drawing, they identify the point of common coupling. We would be interested in that. And then as you follow the electrical circuit down into the premise system, any transformers that are required to convert any voltages up or down to a utilization for the site equipment that's required for operation would be something we'd be interested in. If there is a ground bank or a reactor, neutral reactor, that would be required to be shown. And as well as the in general arrangement electrically of the inverters, and as that if that transfers down to collector panels or whatever the distribution arrangement makeup is down to the panels. And then once they get down there, if they are the same, you could, you know, put notation typical for 1, for 3, for 5. That type of notation would be acceptable as long as it's clear to the user what is being represented. As far as, so that's the physical symbology of a drawing. Now, also of interest is notation or some kind of a text describing parameters, the electrical parameters of equipment. So when we get into, for instance, transformers, knowing that transformer's configuration, if it's a delta grounded Y, YY transformer, or whatever type of configuration the transformer might be, that type of information should be represented on the drawing. The impedance of the transformer should be represented on the drawing, as well as the size. For fusing characteristics, the type and the size of the fuse should be identified. And other general characteristics that would describe ratings or size for overcurrent protective devices or switching devices should be represented on the drawings, as well as naming designations. That's also critical. Having each component named, so when we go out in the field, and we can look that the customer switch 501 on the drawing is customer switch 501 in the field. That takes, it helps connect the physical, or it helps connect the site installation back to the actual drawing. So if there's any confusion out in the field, labeling of equipment will also help us determine which device it represents, or which device on the drawing is representing the item or device installed in the field. So I think we've talked enough about that drawing, Tim, so we should probably advance.
Yep. All right, so then we'll move on to the 3-line.
Yeah, yes, please. So the 3-line drawing is going to be, so everything that I said about the single line is we're gonna transfer that knowledge, right, that I just shared in concepts to the 3-line diagrams. And so the first question I would ask, if this was new to you, would be, well, why do I need to have a single line diagram versus a 3-line diagram? And with most cases, if it is a 3-phase or a if it's a 3-phase service, the 3-line diagram will be required. And the reason for that is because once we get into three-phase diagrams, if you represented for instance, a delta Y transformer, which is, I pick on that because this one's has a delta Y transformer in this image. So with that, in the three-phase representation, it's more readily apparent that that is exactly what that transformer is because you have to actually physically draw it that way on your three-phase or three-line diagram. If it was something other, it would be apparent as soon as we looked at the three-line diagram what that device may be. And that would hold true also for any instrumentation transformers. If you have three-phase voltage elements going to a relay, those voltage elements may be wired up as a grounded Y type configuration, and we would see that, and we would be interested in that type of arrangement, the specific arrangement of the voltage transformers to make sure we are confident that the relaying will work properly or that the arrangement is something suitable for our system connection, and as well as the three-phase connection of any type of ground banks or such, so we can see that. So the three-phase elements are more accurately represented on a three-line diagram versus notation on a single phase.
All right, good. Thanks, Chris. And we'll move on to the AC/DC elementary.
Yes. So this would only hold true on an AC or DC elementary if you have some kind of a logic function outside of what's encompassed inside of your inverter. So, and I say that, so if you had some kind of a relay, for example, we would be interested in the ladder logic diagrams showing us the inputs and outputs of the relay, their functions in which they are associated with those inputs and outputs, and the test switches which are connected as well to that relay for isolation and testing. So really that's going to give us a picture of any logic functions that are being processed with a protective relay.
Okay. And we'll move on to the electrical assembly diagrams.
Yep. So we already talked about this quite a bit as well when we were talking about submitting a drawing and the detail level. But we can talk a little bit more on the electrical assembly drawing. This paints a great picture of what's on a pole or a physical piece of equipment. If you had a pad-mounted switchgear or a pad-mounted transformer device, having a physical representation to show us the details of grounding configurations or bonding points or overhead wiring, we'd be interested in the phase separation and the distances of the wires, the equipment mounted on the pole from ground. We'd be interested in the swing handle, which is, in this example, you can see the swing handle on the pole. And all those things are important to us for different reasons. And by showing that information, we can tie this back to a plan drawing view and understand in a two-dimensional space what that three-dimensional physical installation is supposed to look like. So now if you have different poles, so for example, if you have one pole that is a three-phase gating operated switch, and then the next pole may be your overcurrent protective equipment, and another pole with the metering and the metering equipment, having an illustration for each one gives us the full detail that we're looking for in order to make sure when we look at the drawings, everything that is presented is presented in a manner and includes all the required equipment that we have for interconnections.
Okay, thanks, Chris. Hopefully everyone was really listening on that, because the biggest thing we notice is a lot of these dimensions don't get included on the drawings, and those are absolutely required. And Chris went over a very exhaustive list, but it's very important to have things like that on these drawings. So then we'll move on to relay settings, Chris.
Okay. Were you going to advance? Is there?
Can you see it? I did advance the screen.
Oh, it's just a delay then. There we go. Okay, so not a lot going on here. This is actually just a snapshot from a software program from one relay manufacturer. But for relay settings, if you have a separate relay, we would be very much interested in whatever relay functions are required. So in this one, there's some ground overcurrent pickup times and some time delays that are there, that we would be interested in seeing those types of settings, what your pickup settings would be, what your delays might be. And so this is showing a snapshot from a single manufacturer's software for programming the relay. We would require, if you had a relay, to submit that relay's data file and its native format. And then we would take, and we have the ability to open a variety of different relay data files. And we would look at the data file in its native language and make sure that the settings that we agreed upon are the settings that are being developed to be installed into the relay. So now that's with a regular relay that you would program that would be external to an inverter, something such as a recloser or a relay for a medium voltage breaker or something of that nature. If it was settings for some kind of a breaker and the settings were dial settings or some other kind of a program setting where you would interface with a graphic interface on the breaker itself, we would require you to submit a list of those settings in order for us to do a proper coordination review with our upstream devices. As far as inverter settings go, those, again, are going to be treated similar to like that graphic interface on a breaker, to where we would require you to submit what those settings would be programmed to be in the inverter on some kind of a list or the drawings, some format to where we can look at them and say, yes, we agree with the settings for the over and under voltage and over and under frequency settings, and we can, go ahead and move forward with the project. And of course, having these in our possession, we would fully intend to go out and witness test and inspect those devices to make sure the settings that were agreed upon are now in place on those devices or pieces of equipment.
Okay. Then we'll move on to the labeled equipment.
So I already spoke to this a little back with identifying items on drawings, but again, labeling is very important, especially when we get towards the devices that are of mutual interest, is the term we like to use. So when we get to the three-phase gang-operated device, the pole that houses the metering cluster, or holds the metering cluster, the poles that have the customer's primary overcurrent protection, all those poles and all those equipment should have some naming designation. Now, for customer polling, we like to start with the letter C for customer on the pole. So if it was C1, 2, 3, 4, having some designation where it was customer pole 1 or 100 or 101, 102, that kind of naming designation really goes a long way when it comes to our system operators coordinating with whomever the operator is on the customer's end when it comes to switching protocol or speaking to outages or outage management. But having those labels, again, makes it very clear once we put those labels out in the field, if you're going to troubleshoot a certain thing like your main service over current protection, if it's, for instance, a recloser, giving that recloser a naming designation such as R100 or R1 or R whatever suits your specific site needs would give us detail, and then when we go out there for a field inspection, we know exactly what that device is and what it is supposed to do.
Okay. And to Chris's point about the labeling, you can see on this drawing here, this one's labeled C1, switch C511. It's the gang-operated load break. The fuse is labeled. The second pole is labeled C2, third pole C3. So all those designations are extremely important. From there, the detailed cut sheets, these are always important. And Chris, I'll let you go into that.
So a lot of information you provide us is something someone placed on a drawing. So they drew it, they copied a symbol, and whomever assembled that drawing clearly has an understanding of your site-specific needs. Now, in order to tie all that together, there are certain symbols we use. For instance, on this one we show on the drawings, and none of these names mean anything. We're not promoting any individual manufacturer, but for instance, there's a three-phase switch on one of the drawings or cut sheets that are shown here. Now, we would require that three-phase switch cut sheet to be submitted to us because there are items that would be described on the cut sheet that you could describe on the drawings, but we want to confirm that they meet our standards, such as mechanical stressing of equipment for for our three-phase switch installations on the cross arms on the poles for your point of attachment. Items such as the load breaking capability or fault current or interrupting duties on equipment. The voltage rating of insulators, so we make sure, or the BIL rating, to make sure that the BIL ratings are meeting our minimum standards. Ice break for the operation of disconnects is important to us. All these things are defined as characteristics in our ESBs or electrically defined parameters that are standard across industry that we want to review to make sure that all the equipment that's being submitted is in fact going to meet our minimum standards and are going to be satisfactory for the specific installation at hand.
Okay. And then data sheets are always a big question amongst the developers and customers. So again, if you can go to ESB 751, and there's definitions there, or at least some input on what's required for data sheets, what it should show, so on and so forth. So please refer to that. All right, so moving on. Now that we've have our approved design, National Grid can begin its construction on the customer site. In order to do so, though, we need to have that access road completed. I know we mentioned that way back in the beginning, but now that access road needs to be in so our trucks can gain access to the site. And obviously it has to be loaded for our trucks, for our line trucks. And then from there we can, once we complete our construction, the customer completes his construction, our engineers can go out and do a field verification and inspect the installation to determine if it conforms with the accepted design. And then we can move on to see if, then the customer can provide the certification letter, which really states that the installation on the field has met all the requirements based on the approval design. And from there, once we get the electrical inspection, we can start moving on to witness testing. And before I move into witness testing, Chris, is there anything else you want to say?
I want to talk a little bit about the PE certification and the AHJ inspection. So the PE certification level is whomever, and the PE certification is only going to be applicable for drawings that require PE stamps, just to be clear. But that certification letter is something that we want from your engineer, whomever is the one who performed the design and signed off on the design, to inspect the site themselves to say, yes, the site has been installed per the design that we wrote on paper. And this is just an extra step so we don't have to go out there and try to do our site visit and inspection and come across something that maybe wasn't communicated right through construction with your own internal teams, so we don't have to burden the process with going out, scheduling that event, finding some kind of an error that could have been caught through the internal reviews, and then having to reschedule that event, and it delays the process. So the faster the internal teams that you've selected to do your construction and engineering can agree upon the site being satisfactorily installed, we get that letter, and then hopefully our inspection, honestly, is quite a boring or a mundane process because everything would be hopefully installed per everyone's communication, and we don't find or come across any issues. So now with the AHJ inspection, if an AHJ inspection is required for the site, which is governed by New York state laws, we would require that AHJ to provide a signed inspection authorization or letter identifying that it was inspected and it has passed inspection. Now, there have been times where the AHJ has opted to write caveats or exceptions to that inspection, such as the secondary electrical installation passes inspection and maybe some notation that indicates that they did not inspect the primary. Those types of letters are not, we don't accept those kind of letters for partial inspections. We would like the inspector to cover the entire new electrical installation and not take any exceptions to any new installations. So we know that someone has looked at and approved that installation. We, from National Grid's perspective, are not going to give authorization of a proper electrical design on-premise wiring. We may have knowledgeable people that are aware of what is and is not a safe or a proper installation, but we are not the authorities having jurisdiction to grant that qualified or safe inspection.
All right. Thanks, Chris. So now that the field verification is complete and accepted, we can move on to scheduling of the witness test. It's also important for the witness test that the sequence of operation, the energization plan, the testing and commissioning plan, the maintenance plan are completed. And again, you can refer to our ESB 751, Section 5, and Section 7. Just to give you an example, I pulled those out and put them in this slide here. Just gives a little write-up on each one, what's required for each, so on and so forth. You can also touch base with us. We'll take a look at them and let you know our comments. And then once we get done with the witness test, we'll give permission to operate upon successful completion of the witness test, and we'll download the as-left relay settings. So we've talked a lot about all the drawings that are required. We showed you some progression of like the site plan and how it should progress throughout the construction process. And we always refer to a lot of information within our electric service bulletins. Here's the link to our website for those bulletins. You can find a complete list of those bulletins there. Please look at those and refer to them often. Also refer to the CESIR for any comments that are made in the CESIR for your updates. And I think, Gene, you're up next. Yep.
Okay. Thanks, Tim and Chris, for a great presentation. And bear with me one second. Okay. So did you change the slide, Tim?
Yes.
Can you hear me? Yeah. Okay. Just a delay. All right. So the in review, for some reason it's not changing.
Yeah, the review slide is up, Gene, if you just want to refer to your notes.
Okay. All right. So the initial site visit kickoff meeting and any submittals prior to that, there are opportunities for our technical folks, engineers, to make some assumptions. So one of the things I wanted to reinforce is that how important it is to have a complete submittal in the construction phases. I've heard many times, you're holding my project up for a fuse cut sheet, you're holding my project up for a grounding transformer cut sheet. So I wanted to stress that when our engineers, both our protection and our DPAM engineers, are reviewing a project, they're looking at the entire substation through that entire DG project, the other DG projects on that feeder, and other components and large customers on that feeder. So the completeness has to be there for that final review to be done. And we can no longer make assumptions once we get to this process. So an entire project can be held up on, a simple technical document. And I wanted to have Chris just discuss a little bit, for example, on fuse curves and or grounding transformers. So Chris?
Yeah, so those two items seem to be, and then you could throw reactors in there with the grounding transformers. So those two or those three items are very critical to the acceptance of a final design. And the reason being is because we have to take, for instance, fuse curves, or if you have some kind of a breaker or automated device, we have to take the curve characteristics of that device and coordinate that with other devices on our circuits. So having the specific curves for a fuse or specific settings or curve values for a breaker or some other device is very critical and essential for us to complete our design review and model that with a coordination study with our circuits. So that's why those types of elements, for instance, the fuse curves, are important. Now, the grounding transformer impedance, or the grounding transformer and something like a grounding reactor or a grounding resistor, Same concepts, just a different device. We have to have that information because that ground transformer impedance or reactor impedance or resistor resistance is going to have a significant impact on the expected performance of our ground fault on one of our circuits. So having the proper impedance or the specific impedance of that device to model for us to make a determination is something that is absolutely critical for us to finalize design. We can't finalize design until we have settled on an acceptable impedance or resistance value for that grounding device.
Thanks, Chris. So I just wanted to bring that up because I've had that question several times on, why are you holding up my project? Well, it has to be all-inclusive. It can't be a component missing or a document missing for them to make a final decision. If anybody's reviewed, and I know most of you have, reviewed a set of documents like this, there's nothing worse than having 95% of what you need and having to stop and then go back and pick up where you left off once those documents arrive. And usually you're under a gun and you have a backlog waiting for you. And so if we can make sure when we deliver we have everything we need, we're going to all save time and money and resources. So next slide, Tim. I think we're done. Okay.
You did have one more slide there, Gene.
Okay. So we're going to continue this webinar series. We call it an outreach. And, if you can send me anything that you'd like to see or learn more about what we do. But our next plan is to go through what we review in the submittal process and maybe show some examples so people, again, can understand the impact of a DG system on our systems and why the review process is so important for our number one cause, which is safety, and number two, which is reliability. So next slide, Tim.
That's it, Gene.
Okay. All right, we've got contacts here, and I think Nancy, if she can, is going to jump back on for questions. Nancy, are you there? Okay, so I don't think Nancy's going to be joining us. So anybody that has any questions, you can send your questions into us through the DG portal, or you can email them to us through the Distributed Generation Services website, and that is Distributed Generation Services-New York, no spaces, at nationalgrid.com. That would be Distributed Generation Services-New York at nationalgrid.com. This webinar was recorded, and the recordings will be made available. We'll email them to the participants, and it's also going to be available on YouTube on our website. And I believe, unless someone else has anything else, that will conclude the webinar.
We do have a few minutes. I don't know if the chat function is working. You can possibly use the chat function for questions.
I don't know how to use that, Tim. So.
All right. Maybe not.
This is Nancy. I thank you very much, everyone, for contacting us with concerns. We will work on the webinar and the WebEx issues and availability and improve upon it as we go along. I did want to remind you, you can use the Contact Us button as well in the portal for an inquiry, and we can answer questions that way.